We are going to explain. We are talking about the determination of iron in dietary supplements. As we have talked about in your last videos, you have iron supplement. It is iron sulfate. It was powdered, placed in a beaker, and it was added 100 milliliters of diluted nitric acid. The mixture was boiled during 20 minutes. Then it was filtered and transferred to a 100 milliliters volumetric flask. And then this solution is too concentrated for it to be quantified using a colorimetric assay. So this sample was diluted. We have used the four different uh, chrom- we have used the four different assays. You have used the cyanide assay, the gallic acid assay. For example, for the gallic acid assay, this sample was diluted 2 milliliters of this sample was diluted to a final volume of 10 milliliters. For Prussian blue assay and for cyanate assay, this sample was diluted 10 times. In the salicylate assay, 4 milliliters of this sample was transferred to a 10 milliliters volumetric flask, and the volume was completed to 10 milliliters. Then, for the colorimetric assay, 0.1 milliliters of this sample was placed in a cuvette with 1 milliliter of salicylate assay, and the absorbance was measured, and the absorbance was converted in concentration using the external calibration curve. So you can do these assays using a spectrophotometer and measuring absorbance, but you can do it also using digital images carried using a flatbed scanner. Uh, so you have this this paste was provided in a link in the description of this video. You have this spreadsheet that I am showing in here for you. This spreadsheet will be used to organize the data taken from the digital image. So you prepare a series of standard solutions and of samples. These standard solutions that were used for external calibration curve and the solutions which were prepared for the sample analysis were placed in a 96 microel plate. So uh, samples and standards were placed in the plate as shown here. For example, in these two wells, we have the blank. The first calibration standard was placed in here and in here. The second calibration standard was placed in these two wells and these two wells. The last calibration standard, the most concentrated standard, was placed in these two wells and these two wells. In here, we are showing the data, the image obtained with the cyanide assay. Uh, as we talk in the manuscript, iron 3 reacts with cyanate to provide a, a head blood a blood head complex. We have analyzed the two iron supplements. The first iron supplement were placed in here, in these wells, and the second one was placed in these wells. So you can extract red, green, and blue values of these wells to to plot the external calibration curve and to quantify your samples. You might measure red, green, and blue values uh, of each one of these wells but it is a very time-consuming process, and it is also boring. You can do this automatic. You can do this in a very fast manner using ReadPlate. You can do this using ReadPlate. It's very fast and also very simple. I am showing to you how to do it. First place, we're going to open ImageJ. You are going to File, and you are going to open your plate image. In this case, you can find the image that I am showing to you now in the page that was provided in the description of this video. You are going to open your plate image. It was opened. You can extract red, green, and blue values of this image using ImageJ plugin. It is ReadPlate. The first thing that you have to do is to take note of the position of the first well of the plate. And then you must take the center of the last well of the plate and take note of the coordinates. Here we have 2,592 for the x-axis, and for the y-axis you have 1653. You are going to plugins. You have to go to the ReadPlate macro, press enter, and you have to select the color that you are going to extract. We begin with the head value. You are going to type the position of the first well. So 240 and 198. Then you are going to type the position of the last well of the plate. That is 2601. And then 1674. We're going to press OK. And ReadPlate have extracted all head values from all the wells. You are going to click OK, and you can see that ReadPlate have extracted head values from all the wells. For example, this is the main head value of the first well of the 96 micro-well plate. You are going to press Ctrl A, select all, and we are going to the Microsoft Excel spreadsheet that I have provided to you, and we are going to put the head values quite in here. Ooh. Something goes wrong. So you have copied all these values. You are going to here, and we are going to paste these values in here. Now we are going to select the average head values, and we are going to insert these values in here. I have using a Portuguese version of Microsoft Excel, and in Brazil we use comma instead of points. So in this case, I have to change the points by commas. But if you are in the United States, you don't need to do it. Now it's done. Well, I already did this procedure for the green and the blue values. You are going to do the same thing. You are going to extract green and blue values, insert these values in here, and you take the average values and place the green values here and the blue values in here. Now, the spreadsheet will calculate the external calibration curve for you right in here, and which also will calculate the item mass in each one of your samples, as shown here. How this spreadsheet do this calculation for you? Well, first place, you have in here your working solution. In here, you have your stock solution concentration, and in here you have your working solution concentration. Well, in here, I have the mass of my iron standard. In this case, was iron trichloride. In here, I have the molecular weight of my iron standard. In here, I have the stock solution concentration. Prepare that I am in here the mass of my standard, the molecular weight of my standard, and the volume of the volumetric flask that I have prepared my sample. I have prepared my sample in a 100 milliliters volumetric flask, so it was 0.1 liters. My iron standard was in milligrams, so my concentration was in millimoles per liter. In here, I have the dilution factor of my stock solution. I prepare my working solution, diluting my stock solution. In this case, I have diluted 1 milliliter of my working solution to 10 milliliters, providing a 10 times more diluted working solution than the stock solution. In here, I have multiplied my concentration, which was millimole per liter, by the iron molecular weight. So I have my concentration here in milligrams per liter. I have added 0.02, 0.04 milliliters of my working solution in 5 different cuvettes, and I have mixed 1 milliliter of my chromogenic solution, which was 0.2 mole per liter potassium thiocyanate. In here, I have my concentrations. Look how my concentrations were calculated. How my concentrations were calculated. I have in here the concentration of my working solution. I have the volume of the work solution that was added to the cuvette, and I have my final volume that was 1.1 milliliters. So in this column, I have my concentrations, and in here I have my analytical signal. How this analytical signal was calculated? In here, I have the head values for all my standards. In here, I have the head values of my blank samples, and in here I have my head values for my standards. I have divided the average. I have divided the average head values for each standard by the average head value of my blank, and I did the analytical signal as a log of these values, as shown here. I have calculated the slope. I have calculated the slope and the linear coefficient using the leanest function. The leanest function was shown here. Once again, my Microsoft Excel was in Portuguese. In Portuguese, progeling was right. Linast function was written as progeling. But don't worry about it. When you open this file, this spreadsheet in your computer, if you have the English version of Microsoft Excel, all functions will be changed automatically. In here, I have the head values of my samples. In here, just shows head values were converted in analytical signal. And in here, using my external calibration curve, in here, using my external calibration curve, I have analytical signal converted in iron concentration. Please observe that iron concentrations were calculated using the analytical curve as shown here. In here, I have the concentration of this solution. I have to convert it in iron mass, multiplying my concentration here by dilution factors, and then multiplying it by the volume of my volumetric flask. So I can convert the concentration here in iron mass. In here, I have placed the dilution factors. In this case, the dilution factors were 11 and 2.5. It was 11 because I have diluted 11 times this solution when I reacted with my chromogenic reactant. And I have diluted this sample 10 times. 10 times because I placed 1 milliliter of the solution in here and diluted it to 10 milliliters. So in here I have my dilution factors. I have my dilution factors, and in this case we have 11 and 10. I have placed these values in here, and I can calculate my iron mass. It is a very simple procedure. You can do it very easily using ReadPlate and the spreadsheet that I provide in the description of this video. This spreadsheet was also provided in the support information. Observe that in here you have the iron mass determined in just samples. Many thanks for your attention.